Hello, everyone, and thank you for joining me. Every data team I have ever been a part of is always incredibly busy with a very long list of things that need to be done. Today, I want to share with you a list of things that usually land at the bottom of those lists, or sometimes they don't even make them. I'll try to explain why these things are forgotten, but also why they're important and how to address them. However, before we dive in, let me quickly introduce myself. My name is Veronika Durgin. I've been in the data space for over 20 years. I've held various roles at different companies over those years, with my current role of being the Vice President of Data. I have two kids. I gave myself a title of the Chief Mom Officer because while running a household requires some serious skills and experience. I have a master's degree in software engineering. I am also a certified data vault practitioner and a Snowflake data superhero. As you can see, I have this amazing avatar at the bottom right of your screen. You can connect with me on LinkedIn by scanning QR code on the bottom left of the screen. I really love to connect with like-minded data professionals and have meaningful conversations. My opinions are my own and do not represent those of my current or my former employers. So the items on my list today are in no particular order. Each item truly deserves its own talk, but since we only have a very short session, I will try to focus on things that are often forgotten. All right, ready to dive in? Okay, number one, the forgotten bucket of work. There are overall three types or buckets of work that occupy the time of every data team. Number one, business projects. This type of work creates new capabilities, new insights, new data products. This is usually a strategic advantage or operational efficiency type of work, and it's aligned with the company goals. This bucket of work is usually implied when discussing delivering business value. Okay, the second bucket of work is unplanned work, such as bug fixes, crashes, escalations. This is always urgent and unavoidable type of work. The third is the one that's often forgotten. This bucket of work is dedicated to enhancements, fixing tech debt, addressing orphan backlog issues, and keeping the lights on. This is the time we dedicate to fixing inefficiencies and shortcuts that we took in order to deliver something faster. This is the time we iterate to make improvements, upgrade software, integrate new tools. This is also the time we can spend on testing new things out. This is often the unglamorous part of our work, and it's sometimes difficult to tie directly to monetary business value of a specific project. But it's the type of work that we must dedicate some percentage of our time to. When tech debt accumulates, not only does it cause issues, it actually makes us move slower. When our code is dirty and doesn't follow standards, our system becomes very fragile. And ultimately, we actually end up spending most of our time on fighting fires of the unplanned work. When we don't dedicate time to test new things in order to keep up with the changes around us, and there's so many changes that are happening in data space right now, we're pretty much stuck, left behind in the legacy purgatory. All right, number two, hidden cost of build versus buy. I'm going to maybe exaggerate a little bit and oversimplify this a little bit. So there are kind of overall two camps of thought around build versus buy. The buy camp follows the path that when a turnkey solution is available, the choice is to buy. There is another camp to build, usually driven by engineers that just want to build. I'm here to tell you that we really need to look deeper at the total cost of ownership of a specific capability, whether we choose to buy or build. So, number two, hidden cost of build versus buy, which is the total cost of ownership. So, here's a high level decision diagram that might be helpful when deciding on whether to build something or to buy something, whatever makes sense to you. But let's look at the list of additional considerations for each approach that add up to the total cost of ownership and might lead to a different decision. Okay, let's start with build. I'm an engineer and I love to build. Hands-on work is also how I learn, but it's not enough to just write code. Any type of development requires some sort of a development tool and an environment. This is not free, it comes with a cost. The next thing to consider is whether the team has the appropriate skills and capacity to build. Let's say you want to build something in Java because it's more appropriate for the solution, but your team only has expertise in Python. Would you go with what your team knows and potentially sacrifice some options you'd get with Java, or would you invest into training your team or hiring new resources? Again, all of this adds up to the total cost of ownership of your solution. Once the product is built, who will be supporting its operations? Is this your team? Does your team have capacity to take that on? Or if it's a different team, do they have capacity and skills to take that on? If you need to hire someone else or provide training, that adds to the total cost of ownership. And of course, don't forget about the cost of actually running all of the non-production and production infrastructure to support the new capability we're building. Okay, now when we consider buying, it might seem that the only cost is the software licensing cost. That is not the case either. In the new world of consumption-based pricing, we really have to pay attention to whether the pricing model will scale when our consumption goes up, but also if our consumption goes down. This is especially important for multi-year contracts. Will you get penalized if you use less than you predicted or more than you predicted? Is there a maintenance cost associated with the new tool? Is this a software as a service tool, or does anything need to be installed on an internal infrastructure? If it's an installation, there's a cost to manage and maintain this infrastructure. We have to set up monitoring, we have to have high availability disaster recovery, we have to patch this thing if necessary, we have to upgrade it. And obviously, this infrastructure is not free either. Another hidden cost is that oftentimes we have to customize software that we buy to accommodate uniqueness of our business. This takes time and requires internal resources or an additional cost of professional services. All of these things add up to the total cost of ownership of our solutions. Okay, number 3, definition of done. Okay, I really like this definition by the leading Agile. The definition of done is when all conditions or acceptance criteria are met and ready to be accepted by a user, customer, team, or system. What I especially like about this definition is the call out that someone or something must need what we're delivering. It's a reminder that we do not build just for the sake of building. There is always a user, customer, or system that require our deliverable. To achieve this definition of done, I strongly believe that every ticket and task needs to have an explicit list of success criteria. So here are the things that I think should go on this list. Number 1, complete development based on requirements. It could be to ingest a new data set. It could be to integrate data with some other data. It could be to create a new report, perform some analysis, run some machine learning. But know that dev complete does not mean it's done. The definition explicitly calls out that whatever we created must be accepted by a user, customer, or process. Step number 2, validate data. This is not the same as user acceptance testing. Because we work with data, we must validate that any business rules and transformations are correct, and potential data inconsistencies and nuances are identified, addressed where appropriate, and documented. We must establish data SLAs. It's part of the success criteria as well. An SLA might be that there is no SLA if this is just a one-time analysis. I will cover data SLAs on the next slide. We have to set up monitoring and alerting where appropriate. This might require us to hand this over to a different team. Explicitly list this in your success criteria as well. If our work is a piece of a bigger project, we must ensure smooth handover. I've seen this one too many times when tickets get closed without handovers and just disappear in the void. List this as well and be very, very explicit who this work should be handed to. You could argue that some of these can and should be automated, and I absolutely agree with you. But I also think that listing them out actually helps us understand why we're working on on a specific task and how it fits into a bigger picture. Number 4, data SLAs. Okay, data SLAs definitely deserve their own talk. There are tools on the market and a lot of information about data SLAs. But I want to make this very simple and focus just on a few areas. While it was okay for the data warehouse to be a day behind in the past, it's no longer the case. Fresh and timely data is becoming more and more important to every business. But just like we can no longer have data delayed by a day, we don't necessarily need for all data to be near real time. Defining data SLAs is important both from cost perspective, because running and processing that we don't need actually costs us money, but it also helps us define escalations. Not every failure has to trigger a pager alert. While alerting is important, some could be addressed during business hours. So for the purpose of this talk, I think about data SLAs in two dimensions. Number one, data freshness, or what is the acceptable data delay? For example, in some cases, while it's important to keep very low data delay during business hours, no one is looking at the same data at night. An overnight failure in this case can be addressed the first thing in the morning. As we deliver our solutions, it's also important to understand whether, in the case of data delay, data consumers are okay with data being stale, or if they actually expect to see no data at all. The other dimension is data completeness. If there is a bad record, is it acceptable to skip it, or does the whole process need to fail? This is actually a very common case when receiving data from partners or third-party vendors via files. If there is a bad record, is the expectation that the entire pipeline stops and then alerts, or can we reroute bad records to an error log, alert, but process everything else? We oftentimes check for when data is missing, but it's also important when the number of records is much higher than expected. Late arriving records are pretty common when dealing with any type of queues. Is the expectation from your users that they see data as is? In other words, updated to show the most current version as the records arrive? Or is the expectation to show data as was by creating point-in-time snapshot to ensure consistent look back? And the last thing is referential integrity. We could have data ingestion pipelines that move data in parallel, where a child record could be moved before the parent record. If this is the case for your pipeline and referential integrity is important, make sure to use appropriate inner joins between child and parent table and not just query child table. Once data SLAs are defined, they need to be publicized and easily accessible by everyone using data at your company. It helps avoid unnecessary panic and escalations. If any of the SLAs are violated, the issues need to be transparently communicated to the users. Don't expect to know every single user that uses your data and in which way they're using it. Make sure that your SLA violations are transparently published. We need to create proactive monitoring, alerting, and runbooks, not just for SLA violations, but also to trend anomalies. And do not forget to ask about your tool and data vendors for their SLAs and hold them accountable to it. All right, number 5, seasonality. There is a tradition in the United States to order Chinese food on New Year's Eve. It is a very critical and busy time of the year for Chinese restaurants. They work very hard to optimize their operations to support a large increase in demand. For example, my local Chinese restaurant closes their dining room and only has a preset menu with a short list of most popular items. Seasonality impacts many different industries. For example, in agriculture, planting and harvesting are very critical times. Farmers can't afford for their equipment to be down. You will not see John Deere pushing any sort of software upgrades to those combines. In the US retail e-com, the week of Thanksgiving is when many people shop for the holiday gifts. In accounting, a few weeks leading up to filing of federal tax returns is a very busy time as well. Seasonality is the time of the year when companies have very, very low tolerance for downtime. All of these companies implement very strict code freeze policies to reduce the risk of that happening. How does that impact data teams? Well, if you were asked to stop code deployment to production, can your data ops process still support continuous development and deployment to just lower environments? And when the code freeze is lifted, can you handle production release that can contain a large number of changes? These are some of the things that we have to take into consideration when setting up our processes and technologies. During these busy times, it's also common that there are much larger volumes of data flowing into our systems. Can our environments scale up to support more data and then scale down when the season is over? During this time, there also needs to be a fast lane set up for fixes should anything break during this busy time. Code deployments might stop, but data SLAs are very, very critical to uphold. It becomes even more important that your P1, the most urgent escalation, is truly a P1 so that the team can focus on most critical failures because every minute of downtime is very costly to the business. Number 6, dates. This is one of those things that everyone knows about, but yet we keep forgetting, and then we're surprised when we run into issues. There are many, many different date time formats. The first step to getting them right is to understand the meaning of a specific date, how it's used, and what the time zone of the source system it's stored in is. If we're creating a new column, sometimes just date is enough. In some system, a date data type takes less space, so you take that under consideration as well. Other times, pun intended, it's important to get as granular as possible with the time all the way down to nanoseconds. Whatever the decision is, the best practice is to store dates in UTC with the time zone offset. Now, don't forget about time zones when joining tables. It's a tricky data issue to figure out when there is a time zone mismatch between tables. Okay, UTC is a great time zone to store dates in, but it doesn't really mean much to business users, and it requires the mental math of converting time zone offset in your head, and that is actually super painful. While different users might be located in different time zones, there are companies that only operate in one specific time zone. If that is the case for your company, I suggest that you convert UTC to whatever the business time zone is, and that is what you show to your business users. Naming conventions are a way to self-document. Don't make your users guess, make wrong assumptions, or have to memorize date conversion functions. Assigning very clear column names like created underscore DT underscore UTC goes a long way. But if you create a column for a non-UTC time zone, remember to stay away from notations like EST, which is Eastern Standard Time Zone, because it will change to EDT, Eastern Daylight Savings Time Zone, in 6 months. Number 7, self-recovering pipelines. In more traditional ETL, each step was sequential. And if one step failed, usually everything stopped or everything failed downstream. And it was oftenly it was very hard to rerun processes because they all had to be executed in a very specific sequence. It's more common now to decouple EL, extract load, from the T, transform, and I strongly believe into this approach. While we load data only once, it's usually used for various different purposes and transformations. We cannot really create a one massive DAG to accommodate all of the dependencies. Instead, we should think of building in resiliency into our processes. Our transformations should be able to check if new data exists and go to sleep if there's nothing to process. This helps when we have upstream data delays. Our process should be incremental and only process changes rather than querying and transforming all data all the time. We should be able to handle errors gracefully by rerouting them into error logs. These error logs can be reviewed asynchronously by humans the next day. We shouldn't need to fail our entire pipelines. All right, we're getting close to the end. Number 8, data testing. Okay, a typical software engineering org works with multiple lower environments as part of their software development lifecycle. They're usually development, test stage, and production self-contained end-to-end environments. And this works really well for delivering software. However, data teams deliver data. For us to be able to test data product as part of our development lifecycle, we actually need fresh production data. Now, okay, hold on. I am not saying that we have to test in production. As a matter of fact, the purpose of the slide is to tell you that you should not test in production. So here's a list of things we can test in a lower end-to-end environment. Whether our code compiles and can be deployed, we can take a first pass to validate data types, primary key, foreign key violations, null values. We can also take a first pass at validating data grain for what we're delivering. We can test referential integrity, and lower environments are also a really great place to perform end-to-end testing, meaning that we can ensure that data inserted into the source database makes it all the way to the analytic solution we're building. But that is not enough to ensure that data products we deliver are cost-effective and meet data quality SLAs. To test these things, we need to have a version of data that closely mimics production. This is the only way we can really validate accuracy of data. And the best way to do it is to perform validations on a recent copy of production data. My advice to you is you should really move away from testing in production directly and come up with a strategy that enables you to get frequent snapshots of production data. Number 8, environmental impact. Companies have been collecting an enormous amount of data since storage became cheap years ago. Anywhere between 50 to 90% of all data is dark data. Dark data is data that is stored but is not utilized. It could be data that we collect but not use. It could be multiple copies of the same data across our enterprises. All of this data is stored on servers that require energy and water for cooling. More data requires more compute power to process it, which requires more energy and more water. LLMs require a lot of data to train, which requires, guess what? More power and more water. Uh, this is a quote, a really great quote for a great article by Malcolm Hawker called A CDO Call to Action, Stop Hoarding Data, Save the Planet. Highly, highly recommend everyone to follow Malcolm. He shares really amazing content about data management. So this quote says, according to the International Energy Association, in 2020, the data centers accounted for 2.5 to 3.7% of global greenhouse emissions. And this is more than both the aviation and the global shipping industries. Now, this was 4 years ago. Now, with the rise of LLMs, now this percentage is higher. Call to action for all of you. Please review your data stores and delete unnecessary data. Reduce the number of copies of the same data and optimize your code. The faster the code is, the less power it requires, and the bonus point is that it costs you less to execute it. And number 10, the last one, not the least, walk a mile in their shoes. I am sure you have heard this quite often. There are thousands of reports that no one is using. Or maybe you even experienced it yourself where you built something and no one's used it. One of the reasons for this is because there is no product market fit for the products that data teams are building. And this happens sometimes when there's not enough understanding of the domain from the data team and there's no understanding of how users are expected to use this data. So these are the steps that I recommend data teams make to help solve this problem. Number 1, dedicate time to connect with your users, teams, or people that use what you're producing. Also, reach out to teams that don't know what you do at all. Be intentional about listening and observing. This is not about you showing off all of your very geeky data stuff. This is about learning and understanding your business users. Become a user yourself. In software, there's this great thing called eat your own dog food or drink your own champagne. And it's a common practice of using your own products as a way of testing. Getting first-hand experience using your own products every day for various use cases can be quite eye-opening. Learn to speak the language of your business. There is an amazing book called Digital Mindset that talks about the 30% rule. To be fluent in a language, you need to know 30% of words. As data professionals, we need to understand the vocabulary of the teams we're working with and the context they use it in. We should not make assumptions or be afraid to ask clarifying questions. And of course, teach your users the language of data. Invite them to demos, provide training. You'll be delighted to see a stream of new ideas and opportunities when users get more and more comfortable with the data that you're delivering. Thank you so much for joining me today. I hope you enjoyed this presentation. Connect with me on LinkedIn and let me know if there are any other things at the bottom of the data team list that you're working on that I should add to my list. Thank you so much.